and Madison Hickson. And we did the co-op evaluation system. Now on to Tyler to talk a little bit about the project history.
Cool. So as Emma said, our senior project is re-engineering the co-op evaluation system here at RIT. The current system in place that's being used now was made back in 2002. Since then, several teams have worked on the evaluation system, including 2 senior project teams, not including ours. There's a lot of major pain points with this current system. It's not very user-friendly. There's a lot of session timeouts, and it also provides no feedback to the users at all whenever they perform any action in the system. And as Emma said, our main project sponsors are Jim Bondi, who is the Assistant Director at Career Services, and Kim Sowers, who's the Director of Application Development with ITS. So there are 4 main user roles within our system. There's student, employer, evaluator, and administrator. Student and employer are very, very similar. They both use the system to fill out an evaluation, a student on their own progress at a co-op, and an employer on the student's progress at the co-op. The major difference between the two is that the system uses shibboleth authentication, as in with any other standard RIT application, and employers do not have an RIT account to access the system through shibboleth, so we had to create an entirely separate login for employers. For evaluator and administrator, evaluators just get on and can view the employer and student evaluations side by side and either pass or reject or accept the student co-op. And administrator, they have a lot of different features, including form building, user management, email services, things like that. You'll see those later in the demo. So the next couple slides are screenshots of the old system to kind of give you guys a reference of what it used to be and what you will see in the demo. Many of you probably recognize this screen. This is the student form. So if a student signed on, this is an empty form. They would be filling this out. This is an evaluation search. If you are a student or an employer, you wouldn't be familiar with this screen. This is more of a faculty or administrator who are getting on the system to kind of search for evaluations. This is user management. This is strictly an administrator feature, a screen. This one in particular is for viewing and removing, I think, department users. As you can see on the side, it's kind of weird. This is like another pain point. They have 2 separate screens for viewing and removing, and then another tab for actually adding, and we kind of didn't know why that all wasn't on one screen. So, yeah.
So now me and Madison are going to talk about the architecture of our system a little bit. To start off, we had 4 quality attributes that we deemed most important to our system. They're usability, availability, maintainability, and testability. At the end of the day, we ended up focusing most on usability and maintainability. We achieved usability by consistently using the same theme and screen layout on different pages and using modern web design standards. And as Tyler mentioned, the current system provides little to no feedback for any user action. So we made a point to display a message to the user saying whether their action was successful or if it failed and why it failed. As for maintainability, because of the huge scope of this project, we knew that we wouldn't finish with these 2 terms. So we wanted to make sure the system could be maintained and seen through to completion, hopefully by another team after we graduate.
So in our system, we have 5 major layers, the first being the presentation layer, which the user interacts with. We then have the application layer, which the presentation layer calls Spring controllers in the application layer, and the application layer also has the business logic. We then also have the domain model layer, which contains the entities, which are mapped by our Spring repositories and JPA/Hibernate within our data access layer, which gets this information from an Oracle database. So for our technologies, we have Sass, Bootstrap, and AngularJS for our front end. All makes development a lot easier, and a lot of our team members had experience with these technologies. For Java, we used Spring. It allowed us to add web building extensions into Java, and we also used Hibernate as our ORM because it had an object-centric approach. And for database, we used an Oracle database, and this was a requirement by ITS. So now I'm going to do a demo for you guys. Sorry, we have to make a quick change here to mirror so it's a little easier to present. Alrighty. So the first user I'm going to show you is an admin user. Here is search. I'm not going to show you search because we're going to show you that in another user a little later, so for the sake of time, but we just want to tell you that that also, admin users also contain search. So the first feature I'm going to show you is adding an admin user. There's a lot of other features we did, like add department user, add college, and add an actual department, but for the sake of time, I'm only going to show you add admin user. Ooh, okay. There we go. So here you can see all the current admin users in the system. So let's say I want to add myself. I will put my name and then my RIT username. And so what the system is now added you, so what this will allow you to do is when you log in via Shibboleth, Shibboleth will authenticate you and then will send us the RIT username, which we then verify to make sure you actually have the privileges to do all of these features. So once you're added into this, you now have the admin user privileges and can access all of the features that I'm currently showing you. So I probably don't want to have myself in the system, so let's remove myself, and as you can see, that works. So the next thing is for student forms and employer forms. So as many of you probably have done as a student, you've entered forms, but then these need to be built and put into the system. So there's two different pages, one for employer and one for students. Let's say I want to just create a new one. Test form 123. And the form is now created. I could edit it directly now, but for the sake of time, I'm just going to edit one that we've added a few things to. So as you can see, this is a question group, and these are questions. There's toggles to make them required or delete them. So let's say I want to add a new question group. I want to name it info. Text is the header that is displayed to the user. We have a name and a header because the name will hopefully in the future allow for the reuse of question groups. And then we can select, let's say we wanted a Likert question type or a double Likert. You can set the headers of the Likert scales. But for time's sake, I'm just going to select a non-Likert thing. And also you can select where the actual question group will be added. So let's say after additional info. Alrighty, so as you can see, info was added. And now I want to add a question. Let's just make it a very basic question. You can select, make it a required question. And then I want to attach it, of course, to the info group that I just created. How was your co-op? And then this is a more general question, so I'd select a category. I could make my own new category, but I'm just going to use an already existing one. This will allow for in the future reporting, so kind of get some feedback there. So as you can see, it's been added. Let's say I just want to save these changes, so it's saved, and then if I go back, you can see that there it is. And to show you more fully fledged form, let's go here. This form you will actually see later when Casey shows you student. Show you kind of how it would look like as a fully fledged form. So yeah, the next user I'm going to show you is employer. So at the end of your co-op, your employer needs to do an evaluation on you. So they would log in and then come here. As you can see, this person has they've already started their evaluation. So I go and click here. And you can see this is sort of information I've already imported previously. Please identify area, let's say none. then you can save for later and come back to it at any point. A lot of the pain points I know was with saving in the previous system with things like timeouts and things. So now that I'm done with this, let's submit. And it is now submitted. And it's, as you can see, it's now moved to the previous co-op's students because now it is officially submitted and the co-op, they don't no longer need to do anything with it. So I'm now going to hand it off to Casey.
So now I'm going to show you the student role in the system, which I'm sure many of you are familiar with. So here is the overview page. As you can see on the right, you have a previous co-op where the student work report and employer evaluation have already been submitted and it's already been approved. So we're going to look at our current co-op here. So I'm going to click on the open form. Let's refresh. There we go. Oh yeah, one thing to note was, see this said saved earlier, but now it's submitted because Madison submitted that form. Okay, here we go. So up here we have the student information and the co-op information on the current co-op that I'm evaluating. As mentioned earlier, a lot of this should look familiar to you, to many of you that have been on co-op, and I actually do need to go through and complete this because if I don't, it will yell at me and tell me that I still have some required questions to complete. In here we have our Likert questions, and you can see the different scales that the user can input, defining what each number means. One big thing we did change was how you enter comments. These are in modal windows now. So if I just say this is a comment, I can save that, and you can see the button changed into an edit button. And if I open that up again, it's already saved. And just a couple more questions. And now if I submit that form, it says that it's been successfully submitted, and here it is. So now that our co-op evaluation process has been completed, we go over to the evaluator role. As you saw before, this is the search page. It's identical to the admin role. The only difference is that an evaluator only has access to students in their department. So as you see here, we only have one department listed, even though there are multiple departments in our system. And leaving this form blank by default will return all available results. So I'm going to go ahead and do that. Probably had to refresh the page. Keep forgetting to do that. There we go. There we go. So here is one that has already been approved, and you can see that was the previous co-op, but I'm going to go look at the forms that me and Madison just completed. So as you can see, this currently is still pending since it has not been approved or rejected. You can see the employer evaluation and the student work report side by side, and this allows a faculty member to see the student and employer's answers at the same time. If you want, you can also view them individually, which is a pretty neat feature. We actually thought that viewing them side by side would not look good at the end of the day, but thanks to Bootstrap, it's actually responsive and it's really nice. So I'm going to go ahead and approve this. And as you can see, the status has changed to approved and a message displayed saying that it was successful. And that concludes our demo. Okay. Yeah. Shoot. Sorry, guys. Okay. Let's see. All right, so now I'm going to talk a little bit about how we think we did and where the project is going from here. So we had 3 product metrics that we tracked, and one that we used the most was the software usability scale. So early on this semester, we conducted usability testing using all of the clickable mockups Casey and I created in Lucidchart. And after our testers ran through our gamut of tests, they answered a set of 10 Likert questions. This is actually the first 3 that are up there right now. That we then took the numbers and the results, which I'll show you in a sec, to create
a quick and reliable way to measure how well we were doing in the usability department. There are also some questions about demographics and some more open feedback questions, just so we could get real opinions as well as just straight numbers. Okay, so these are some of the results. We took them completely anonymously, so I don't know whose results were whose. All I know is whether they were a student, employer, evaluator, or administrator. So I just got this big spreadsheet, and the formula at the bottom is actually what I used to calculate the final score out of 100. Overall, we tested 5 students, 3 evaluators, 2 employers, and 4 admins. To get the best results, we needed 3 to 4 of each role, so we were a little bit lacking in the employers. But it still worked out. So our final results came in at student being 85.5, employer down at 77.5, administrator 80.6, and evaluator at 86.7. We think we did really well here, considering the threshold for good usability as defined by SEUS is actually a 68. It showed us that all the time we spent on the mock-ups was actually well spent, and it ended up saving us some time in front of development because we ended up having something to just develop to instead of designing as we went. Our other product metrics included code coverage and backlog management index. We achieved 69% of Java lines of code covered, and that's anything that's not like just a container or an entity. Only 15% of JavaScript code was covered. Most of our unit tests were actually written by a co-op in the OCE office, and our JavaScript numbers were much lower since she's just learning JavaScript, and those of us doing the JavaScript development were hard-pressed just to get the functionality in on time. Backlog management index is the rate of the number of bugs fixed versus those identified. We wanted to achieve a score of 0.75, but we actually managed 0.83. Okay, a few things that went well. Usability testing, obviously, as supported by our SEUS scores. We have some of the very best sponsors. ITS in particular was always available to help us push through any technical roadblocks, as well as maintaining our servers and our test accounts for us. Finally, we also had great success pairing up on feature development, one front-end developer to one back-end developer, so we could kind of bounce off ideas and cut down lines of communication when actually integrating. Okay, a few things we could have done better. Spent more time on testing. Our numbers at the beginning kind of showed that. We prioritized functionality over testing. Really should have just started on that sooner. Initial onboarding of our co-op took much longer than we had hoped. Turns out our project is really complicated, and someone that doesn't know the system has a hard time following at first. Finally, with releases, there was always a surprise during our demos, and until last week's release, we never had quite the amount of functionality we were hoping to, but we did end up catching up, and our sponsors were very happy with the progress we made. Okay, so just a quick peek at where we spent our time. This pie chart really shows that this was an SE project. Only 30% of our time was actually spent on development. And just one thing to point out there is that our testing slice is really as small as you thought it would be. We just couldn't get the time in, and also that slice does not count any of the time spent by sponsors and volunteers actually running tests for us. Okay, finally, future work. So we have some tools that were not finished, emails and reports for administrators, and a little bit of that for the departments as well are completely unfinished. This week and next week we have our official handoff to ITS, who will be continuing this project for us. We're hoping this will see completion, either by another senior project team next year or by a set of co-ops in the Career Services office or in ITS. Any questions? Maggie.
So I know that Twitter Bootstrap notables don't always play nice in IE8. So in like a lot of offices that I've worked in, force all of the people to only use Internet Explorer 8. So I'm just wondering, did you cover that in any of your testing? And will your application still work if I'm forced to use that?
Unfortunately, the 4 of us have MacBooks, so cross-browser testing, especially IE, is something that kind of fell to the wayside. Also, to go off of testing in general, our unit test numbers for JavaScript were pretty poor. So it's just, we really wanted to focus on functionality for this because this project has been tried so many times, so that's unfortunately why testing.
Also, if you look at our project plan, it says IE 9 plus.
Oh, also that.
I asked about it early. Mustafa.
I got a question. So your application seems to care a lot about privacy. So how did you actually care, how did you implement the security of this application?
Tyler or Madison?
So it was a mixture of things. First of all, SHIB was in charge of actually authenticating all of the anybody from RIT that could access the actual application. So they dealt with that on their end, and then they had specific classes that would allow us to get that information once they've been authenticated. Also, we then created for each endpoint for Spring, we created privileges. So, like if things like editing a form is only technically an admin role, so we made sure that only when they try to access that endpoint, that only an admin could actually access that. It was a mix, yeah, so the actual security filter initially when you log into the system is just to make sure that you are one of the 4 roles, and then the second layer is on an endpoint basis to make sure that you actually have the privileges to do that functionality.
And if you don't have privileges, you get sent to an unauthorized page, or if you try to access a page in the application that doesn't exist, we send you to a page doesn't exist or page.
Professor McNeely.
So in the same category of security, you talk about availability as being a big concern. So what is the largest number of people you tested out on your system at any given time?
So we actually push load testing off onto ITS once the system is in prod. Right now it's only gotten as far as test. We just don't have the capability.
So you pushed it up. So you pushed off load testing. Why?
Bandwidth, like just the time that we had. Unfortunately, we had to make some choices on what we did and what we didn't do, and unfortunately, we kind of went back and forth with ITS and deciding, with our bandwidth, how many hours per week we had, and what needs to get done, and what features need to be completed. That was one of those things, unfortunately, that we felt that ITS would probably have a better handle on.
And we felt that since they already have a series of applications, that they would have the tools in place already to perform load testing. So,
Whereas we don't.
yeah, and that was an expectation that we set at the very beginning, so it wasn't a surprise.
So then why is availability one of your key things?
We ended up not focusing on that as much. As Casey mentioned, it was mostly usability and maintainability that took the forefront.
I think also what falls under the umbrella of availability is the session timeouts that would happen. So a lot of people were losing form data if they left the page open, came back, tried to submit it. So we mitigated that by allowing people to save their form and come back to it later.
There are also no forced timeouts at this time.
Yeah.
Let's thank the team.
Hello, everybody. My name is Kurt Poquette.
David Wilson.
I'm Dave Pratt.
I'm Jackie.
We are Team Tiger Collect. Our application is called Click. So just to give you a quick overview of what we'll be talking about today, product overview, touching on our motivations, the system architecture of what we have, a demo for you to show you where we're at right now, the assessments of how everything went, and then where this plans to go in the future. So to understand the project, you understand why we wanted to do this. So the main problem that was brought to us was that in dining services and other places on campus, there's difficulty entering information such as menus or hours, and there's multiple places where they had to enter this. The applications they had to use were outdated or unintuitive, clunky, some nearly a decade old. So we really wanted to try and address those situations, not just for one department, but extensively, and then find a mobile-friendly solution of a responsive web application that all these locations would be able to use on the fly whenever they need to. So that brings us to our project. So working with ITS here on campus, we created what we call the Campus Location Information Collection, or CLIC for short. So CLIC focuses on two types of content, basic things like a description of a location or an image about that any sort of place may have, or specialized content pertinent to the specific type of place, be dining services or lab, what type of equipment is available. And we tried to build this so that it wasn't just one department or one or two departments. Then in the future, this is something that could be built on and expanded to various other departments as well. So to give you kind of an area or an idea of where we fit in the bigger picture, we designed Click to take out the web menu tool that you can see up top, and that we were successful in creating an application that will be able to take that place right as we are, or right as this goes. And then you see the map admin tool is crossed out with dashes. The idea is eventually when this application is built a bit more upon in the future, it'll be able to take out that tool as well. So that's kind of where it falls into, feeding the information into InfoHub.
All right, so Click is built by two main pieces. We have the Click website, which is the app, and the Click API. So the website's main users are going to be basically staff at different departments. We have 4 user groups, which would be just location staff who can edit content, be it special or basic content. We have location managers, which have all the privileges of staff, but can also add staff to a specific location. We have department managers, which would be someone who manages like dining. So they get access to all locations under dining, and they get the privileges of a location manager at each location under dining. And then we have service desk, who has access to add anyone to any location. They can add department managers or edit any content to help fix any issues that arise. This app was built to be responsive so that if it needs to be used on a mobile device or just like a desktop or laptop computer, it can fit well on both of those. Edits can be made on the fly, as well as large inputs of data for menus and such can be put in on a desktop where it's easier with an actual keyboard and everything. The API is the main data store and access point for getting all the information. The API right now is only targeted to talk to the website, but in the future, this is where we'll replace the map admin tool. We want external services to be able to call the API and get this information about different dining locations and things that can be populated to different websites.
So moving into architecture, some of the architecture significant requirements that we got at the beginning of the year that really shaped how we went about the project. These are some of the big ones that the sponsors clearly laid out when they defined the project to us. They wanted a responsive web UI, as Dave explained, so that location staff can fix things on the go. We knew that we were going to be using shibboleth authentication, and we also wanted a single point of data entry, which could then be accessed by several different systems. So from that, we split our architecture into 2 different partitions. We have the Click API server on the right and the Click app on the left. Another important thing that we did was we put most of our application logic on the client side using AngularJS and Foundation, and that really helped us with the responsive design so that all we had to do was pass data to the models on the client side, and it would build it however it fits well on the device that the user's using. And then to do the shibboleth authentication, we made a proxy API so that the client isn't talking directly to our API. It first goes through the proxy, which uses shibboleth authentication, so that the API knows what user is using this, so it can handle authorization. So then we'll move into our demo. So we'll start with the mobile view because, of course, that's how you do responsive design. So this is your main page after you log in. It lists all of your departments that you're assigned to. And so in the mobile view, you see it's just an accordion. It shows very little at once, but you can still access everything. But if you're on a desktop device, we have a lot more screen to work with, so we can spread things out. So if I move into Commons now, so this is the location that I'm in. There we go. So let's say, so this is the main page for each location is your basic content. So you have like a description and different URLs. So like if I want to make this grammatically correct, I can just fix that right there and it saves. The next part that we did was hours. So you can, most locations have different hours that they're open, and we handle this by specifying different events. So like this one has a lunch event that's open from January to May at these times. And we can add a new event, say dinner, and we can put it open at the same times. From say 4:30 p.m. to 7 p.m. And you can specify what days it's open. So we'll put that on the weekdays. And so now we have that second event there. Another thing that we were asked to do was be able to have exceptions, because a lot of times things come up or there's like a holiday or something, so the location doesn't always follow its fixed schedule. So say, for example, there's something wrong with the location and they have to be closed for a day. So we can just pick a day. Say we want to be closed on the 15th. This is closed. And we can just check this tick box and say that it's closed. This exceptions also let you just, maybe it opens a little earlier or ends a little earlier or later. And so now we have an exception. And this is, in the future, this might be used for, say if there's an application where you want to know what's open right now, something like that can take these exceptions into account and see like maybe if this location is usually open right now, but right now it's not, so it'll take that into account. The other big area is with menus. So there's two aspects to that. The first one is menu items, and this is organized into groups because most locations have either like different stations or different categories of items. And so we can add a new group. Say Commons has I use grill. And we can add items to that. And so there's your item, and so you've got your different different groups and different items. And these are this is basically a list of all the menu items that this location ever offers. And to actually make a menu, we have to link that with the events. So you see here on the menus page, we have a list of the events that we made, including the dinner one that we just made. And just to go back to how this works on mobile, see, right now you see that it displays the whole week, but if we are on a mobile device, that won't fit, so maybe we'll just display one single day. And so you can change what day you're looking at. And so if we want to construct a menu, we just pick what items we want. Say we want all these items, and so then these items will show up in this section, in this group, on this event, on this date, and that's a menu. Another feature is, since I am a manager of this location, I can actually manage other staff of this location. So maybe I want to add Jackie. So I just put in their RIT ID, maybe I'll make her a manager, and add her, and then she shows up there at the top in green, and then I save changes, and now she's a manager. And right now it doesn't have her name because I didn't put it in, but next time she logs in, the system will pull her name from Shibboleth and fill that in. There's also, this is managing staff for a specific location. Let's say I want to just manage an individual staff. Because I'm also service desk, I have this extra option here where I can just pick any person I want and say maybe I want to make her manager of the entire lab department. So I can add her as a lab manager. And you can also see that she's the dining manager for Commons here that I added before. And so now she's a lab department manager as well.
So these are some of the challenges we faced as a team on this project. We found that it seemed like we were working for the customer's customer because our sponsors, like we said, was ITS, but then the users that would actually be using the system were dining services. So if we had a question that we needed answered about usability or functionality, sometimes ITS wouldn't have an immediate response, and it seemed like two channels of communication were forming because they would have to go to confer with dining services and then relay an answer back to us. Another challenge was the learning curve on the new technologies, because when we first started the project, ITS gave us a stack of preferred technologies they wanted us to use. So a lot of these technologies we hadn't really ever used before, so we had to get up to speed on those. Another challenge was our schedules changing midway through the project when the semesters changed. It was essentially a 5-week break in the middle of the project, and then when we got back, we had to gain our momentum back, get up to speed, figure out new times to meet as a team, and that was sort of a challenge. And our biggest challenge was integrating the hours and menus features that David just showed you. It took long hours of brainstorming, and we had to figure out how we're going to design the way we would lay out the information. We had to figure out how the data would be stored, and that was really challenging, but we figured it out and we pulled through. And our lessons learned, we were glad we learned most of these lessons from the first half of the project. We learned early that communication was key. It was important to keep an open channel of communication with the sponsors. If we didn't understand a requirement, we went back to them as soon as possible, kept emailing each other back and forth because it was really important. We also learned to document all our decisions, so if anybody missed a meeting, we would at least all know where we were, status, and what we had decided moving forward for the project. We also learned that feedback was a top priority. Luckily, we had chosen a methodology that incorporated multiple opportunities for feedback throughout development. And so we learned to incorporate this feedback, and it was helpful for the project. We also learned how to do responsive web development. We learned the importance, especially because it was a requirement for this project, but we saw how it was very useful for developing web applications responsively. Yeah.
All right, so the current status of our project is we have the application on a test server. We're currently trying to start user acceptance testing with dining so that ITS can get some feedback on how it looks. And we had previously met with dining just to give them an overview of what it looks like and kind of get initial feedback. But now they'll actually be able to go around and play with some of the features and get to know the application. The fact that it's on the test server also gives us a chance to get ready for when ITS wants to deploy this to production, so we can give them some guide and documentation of how you would want to go about deploying this application to a production-like environment. This application is set to hopefully deploy in the early summer once we hand it off to ITS, which is what we're currently need to do in the next few upcoming weeks. So we just need to develop some documentation to give them some guides and then about some of the management of the application, and we can hand it off. So for the future plans of this project, the vision of this project is to, outside of dining, which was our main focus for building this kind of as a proof of concept that it could be used for other departments, to let other departments be put into this application and have their special content or basic content be input by this one device, so that all facilities on campus could have this one portal where all the data would funnel through. One of the other things that was desired was customizable content fields, which would be like you can, for a location, you can change what contents fields would show up at a specific location. We don't have that currently. Currently, right now, basically all locations in a department would have the same kind of fields showing up. So, you know, dining would all dinings would have just menus and whatever fields menu had. Ideally, location could have, you know, different menus could have different pieces. Like if one dining location only had a price per item, but one just had a price, like Gracie's for just entry, maybe you don't have a price field for the menu items on that location. And then finally, integration with external services. So one of the main goals for the API, as I mentioned earlier, is that external services will be able to hit the API and get information that's entered through the application about different dining locations or facilities in general around campus. So making the API public-facing as opposed to just going to the web version of.
How much did you guys explore usability? For instance, did you put it in front of potential users or something? I noticed, for instance, when you manage somebody who was a two-click or scan and then save sort of thing, did they ever, do you have any usability testing with the actual customer of your customer?
Not yet. That's part of what we're going to be planning on having done in the next couple of weeks with the user acceptance testing on the test server. To address that specific concern, we did think about that, and we decided that, like for the specific location page, the use case for that would be you have a location, you want to add a bunch of staff to it, so maybe you want to just like add a bunch of staff at once and then save changes, so that like if you make a mistake, you don't like lose all your progress or anything. You can just undo that one thing.
So suppose I work for dining services and I haven't seen the application all year and I'm waiting, you know, expectantly for this. What evidence can you give me that the system will not crash, get hacked, go down, have lots of bugs?
Go for
it. We do have some automated tests for the UI. So like if the ITS has to make a change, they can run the automated test to make sure it doesn't break the system.
You mentioned sort of the response design you were showcasing sort of the mobile window. I'm just wondering what platforms you tested, what versus browsers that you built on sort of site.
We tested mostly on Chrome and also on Internet Explorer because that's mostly what the ITS is probably using. So, and Safari as well.
On mobile devices?
Yes, we did look at a few mobile devices too. iPhones, iPads.
Mobile devices were the lesser. We mainly focused on kind of the bulk of like desktop because that's where bulk entry will be. So while we did look at mobile devices, most of the testing for like browsers and stuff was done through desktop.
And also, the automated UI testing that we use does test the different, I mean, it tests them on a desktop platform, but it does test the different screen sizes as well. Right?
So you mentioned that you had a bit of trouble with communication because you had like a customer's customer too, right? So what sort of things have you tried to mitigate if you actually mitigate it at all?
Yeah. Okay. We did meet with the actual customers once, and then we got a good feel of how they were feeling about the project, some specific requests they had. Like, we saw the direction they were going with their requests, so we noticed, like, we saw that their concerns are mostly about, like, the UI, things like that. They liked the functionality they were getting, so we're sure about the requirements we had gotten so far. Does that make sense? But the challenges we had were mostly, like, the lag in the communication. But because of the way our methodology was, it wasn't very detrimental at all. So even if it took them 1 week to get back to us, we had stuff we're working on that week. Yeah.
The other thing to note too is that if we were going to talk with dining services directly, it kind of felt like we either had to start out doing that or do it at the very end when we kind of had the whole thing built out. Because pulling them in midway when stuff is kind of fluctuating a lot didn't seem like a good idea. So while we showed them a product part like near the end but partway through that wasn't completely done, we didn't want to start getting our requirements directly from them or anything because we wanted to have someone who was invested with it through the whole project and knew kind of the path we went through.
Good evening, everyone. Our project is the Dotto Disaster Tracker. We are the Masters of Disaster. I'm Josue Jimenez.
I'm Aaron Dammer. I'm Brandon Cole. Jacob Peterson.
I'm Isama Chupalo.
Our faculty coach was Samuel Malakowski, and our sponsors who could not be here today with us are Christopher Serafin and Sharon Malfesi, both who we would like to give thanks to. So our sponsor, Dotto, is a business continuity solutions provider. They provide services such as cloud backup, instant virtualization, and disaster recovery. Dotto is the difference between downtime and uptime. However, this means that they are a more reactive solution to disasters. They wanted to have a more proactive solution. Dotto has thousands of devices across the nation, all of them which are prone to disastrous weather. A storm could knock out the power, a flood could damage the devices, anything can happen. So because of this, Dotto and their MSPs, their managed service providers, wanted a way to know beforehand when their devices were at risk and then take the appropriate measures to reduce the damage, hence the more proactive approach.
Okay, so this is our solution. It comes in the form of a web application and a mobile application. Let's dial back the clock a little bit here, back to the winter when Boston was being severely hit by those snowstorms. On the left, you can see multiple devices on the web application. This is what Dotto would be seeing, and over towards the right on in the Boston area, you can see that there are a lot of red devices mentioning that they are at risk. Well, the mobile application, this is more tailored for the MSPs to use, the managed service providers. They have a list of all of their devices and their risk rating on the left side, just to get a quick glance at the status of all of their devices. So our project is based on 4 main goals. The first being to easily identify at-risk items. We want both the managed service providers using this as well as employees at Data to immediately look at this and know that devices are at risk or not at risk. The second being to generate a risk value based on weather information, where we pull weather information from NOAA to accurately and immediately generate any sort of, or change the status of any devices that could be at risk. The third is to provide on-the-go alerts for our MSPs through the form of push notifications. That way, if MSPs are on the go or not at the desk, probably in a meeting of some sort, they can get instant messages letting them know that their devices have now become subject to natural disaster. And 4, to provide the customer with information to prepare. This is, again, our proactive solution that Josue mentioned before, where they're provided a list of steps to mitigate these risks. So we're going to go into a live demo right now. So as you can see, this is our login page. Once this is handed off to Datto, this is actually going to be run through their main website. Right now we're hosting it on a mock data website, mockdata.pk. So right now we're going to log in as a Datto employee. This is all using a real mock OAuth system. These are real credentials, but not necessarily a real Datto employee. It's just a mock of it. So as we log in, it's currently going to pull 30,000 devices across the United States, which was the scope of our project, and populate them on this map and in that data table to the right. So as you can see, there are a lot of colors on this map, from green to a little less green to orange to red, and each of these colors represents devices at risk. So we're going to go and zoom in into one of these red areas towards the Midwest, and see, we got a lot of devices that are in the red over in the Colorado Springs area. So right now, we looked this up. They are suffering from severe thunderstorms over there in Colorado Springs. So we know that all of these devices represented as red dots on our map are now at risk of a potential power outage due to these thunderstorms. And their risk levels have all been updated based on all the weather information that we've been pulling. So this has been both referring to our first project goal, where you can easily tell that these devices are at risk because they're red and most devices on the map are green, which means they're not at risk, and that all this information has been updated through our weather calls to NOAA and our risk algorithm, which we'll be explaining a little bit later in the presentation. So if we zoom back out, we actually have a few additional features to our web application. We can display a weather overlay, which provides a Doppler radar of over the United States. And as you can see, the Doppler radar and the thunderstorms match up with the different risk areas on the map. Again, this brings us back to our second project goal, to provide accurate and on-the-spot weather information to our customers and data. We also have the ability to filter devices. This tailors to our first goal, where you can see more at-risk devices, because just in case you didn't want to see devices that weren't at risk, you can filter them out below a certain threshold and see only devices that are at risk of natural disaster. With our data table, we can do all assortment of rearranging. Right now they're arranged by risk, highest at the top, but we can actually put that in ascending order, or we can order them by ID number or their location alphabetically. We can also use the search bar up on the top to immediately filter out all things that don't match the search terminology. We're going to go to Rochester and zoom in on the click of one of our devices in the data table to just immediately zoom to that area. Again, making it easier for the people using our system, the web application, to make it easier for them to see at a glance what's going on in a certain area on the map. So we're going to log out right now and log in as a mocked MSP. And right now, it's only loading up 20 devices. We located all in the Alabama area. So these are all devices that were listed in Datto's point of view, the Datto employee's point of view, but these are for MSP use only. These would be the devices that this managed service provider used. But as you can see, all of the features with the Datto side of the application carry over onto the MSP side. So we're going to log out, and then Jake's going to give you a demo of our mobile application.
All right, so like you said, this is our mobile app that's a companion to the web app. The mobile app is mostly for use by MSPs as opposed to Datto employees. So we're going to log into MSP2 like he just showed you on the web app. This login is also utilizing OAuth for login and authorization. Yeah, 1 second. PowerPoint videos are always fun. All right, there we go. So as you can see, once you log in, we see the devices that we just saw on the web app, all the devices in Alabama. It's got all the key information you'd think of, the device ID, the location, and the risk level, sorted by risk, just like you saw in the data table. And as you can see, everything's at 0% right now. It must be a nice day out in Alabama. So we'll go to our next video and show you a more interesting scenario. So in this next one, we'll see what happens when devices hit a high-risk threshold. And what happens then is that we'll send a push notification to MSPs to alert them that their devices are at risk. And like Aaron said earlier, this allows MSPs to be as up-to-date as possible on their devices that are at risk so they can prevent any damage. So we're going to go ahead and open this push notification. And once you open it, it opens that list of devices again. And as you can see, the high-risk ones are at the top here. And now you can also see that the devices are selectable. So once you select the device, it brings you into a more detailed view of this device. You can see the same things as you saw on the last page, such as the device ID, the location, and the risk level, but it also now shows you the specific cause of that risk. So this one is a severe thunderstorm warning that's causing an 80% risk for this device in Las Vegas. This view also has a list of steps that we give the MSPs to prepare so that they can minimize their downtime in case of a power outage. So these include steps to help you protect the device, as well as steps to back up all your data and resources so that if your power does go out, your loss is minimal. You can also email these steps directly to your customers by hitting the share button in the corner there, and it'll populate all those risks, and then you can just send them right out. For now, we're just going to cancel this. And then lastly, MSPs can log out of the application if they no longer want to receive these push notification alerts, and next time they log in, they'll start receiving them again.
Cool. Thanks, Jake. So I'm going to dive in and talk about our architecture. We actually had a pretty interesting architecture, I'd say. We had definitely our share of challenges, and so I'll talk about the design decisions we made and sort of the rationale behind that. So first of all, just real high level, the system boundary in the middle, that's our senior project. That's what we were expecting to implement. Right in the center is our set of APIs, so that's our core logic. That's things like calculating the risk levels, so that green and red you just saw in the demos. All of that core logic is centralized in our APIs. And then we have our interfaces, so our web app, our mobile app, maybe a future interface, an Android app, who knows what could come later. I'll just hit the centralized logic, so it's not duplicated across platforms, it's in one location. We have a simple SQL database. And besides that, we have a lot of external systems that we're depending on. So the first being weather, NOAA. We're pulling weather alerts from NOAA constantly, and that's how we calculate our risk, and we'll go into depth on that interaction in a few slides. The next is the push notifications, and that's done through the Apple push notification gateway. And the last one is the Dado API itself. And I'm actually going to zoom in on this interaction particularly between our APIs and Dado's API. So on the left is the senior project team again, and on the right is the Dado stack. So these are APIs that we need from them. So particularly we need login, we need authentication, and so that's in the form of an OAuth server. And the other thing we need is an exposed devices API. So this is how we get their list of devices every day, how we know where they're located so we can plot them across the map, things like that. At this time, neither of those things are in a completed state. Dado is transitioning from SAML to OAuth, and the exposed devices API is not complete at this time. So that was definitely a challenge that we had to face. So it's like, what do we do? So we actually decided to mock that system ourselves. It's all documented, and we made our own implementation. So we have two stacks going right now, and they're communicating with each other. In the future, when Dado does complete that implementation, following our spec, it's going to be as simple as just changing these integration points. So just starting from the top down, again, the daily batch job to update our devices, getting the devices once you are logged in. So once you do that pull request, well, what devices am I allowed to see? And your standard OAuth authentication, token response, auth codes. Those connection points, they'll just simply need to be redirected to the finalized data implementations. So that's why we went with that approach.
And so one of the most important aspects of our system is the risk algorithm, how it works. And so that all begins at NOAA. And what NOAA allows us to do is have a list of weather alerts in XML format that we pull from them. And through that we have 4 specific things that we need: the severity of the alert, the certainty of the alert, and the specific where the alert is and the type of weather. And so with severity and certainty highlighted here, we see that severity is how bad the weather is, certainty is how likely it is to happen. And with those specific things, we associate numbers with that. So something that is a higher severity will have a higher number, say 1. It's a number between 0 and 1. And something that's lower severity would have something like 0.5. The same is for the certainty. And we also have the weather modifiers. And these, in order to associate numbers with those, we took 15 years of weather data and 15 years of power outage data. And in correlating the two, we found out what type of weather was more likely to cause a power outage. As you can see, hurricanes have a higher number versus something like a flood. So given those 3 things, we plug them into our risk algorithm, those 3 numbers, we multiply them, and that gives us a risk for a specific alert. Going through all the alerts, we then apply that risk to all the devices within a UGC zone. A UGC zone is something like, think a county, but smaller. It's how NOAA zones out the entire United States. So all the devices within a specific UGC, we get the specific risk. And once we've gone through all the alerts, we then go through our database of all the devices that their risk is now above a certain threshold, say 75%, we'll have push notifications sent to all the owners of those devices. So, current status. At the moment now, our web API, web and mobile app are completely done. So we've hit our code freeze about a week ago, and so all the stuff as far as the product is concerned is complete. The data stack is completely done. We mostly have project things such as technical report or reflections. It's mostly what is left to do.
All right, so while the project overall went really well, we did run into some challenges along the way. Specifically, the biggest challenge was the risk algorithm that we just talked about. So there were several issues with that. First off was figuring out a way to efficiently calculate the risk for all of the devices. So we do have 30,000 devices. So our original idea was to pull the weather for each device location, generate a risk, and then apply it to all the devices in that location. That turned out to be infeasible because we'd be pulling thousands of times every 10 minutes if we wanted a constantly updated risk level. It just didn't work, and it wasn't inefficient, and it wasn't even possible on most of the APIs we were looking at. So what we ended up doing was finding the NOAA's API for weather alerts, and this turned out to be much more efficient as it allowed us to pull one time every 10 minutes, and it only showed us data for areas that were at risk. The second challenge was data availability. So the weather alerts operate on UGC zones, like you said. So in order to map devices to these zones, we needed to map cities to UGC forecast zones. This information was not readily available, so it was a pretty long process for us to gather all that. And then the final challenge was just accuracy. This came down to a lot of research and trial and error on our part. Like he said, we got 15 years of historical weather and power outage data. And with that data, we created a logistic regression model, which allowed us to get coefficients for each weather type based on their effects and their cause of a power outage or not. And then we use these coefficients relative to one another to find out which weather events would cause a higher risk or a lower risk. And then finally, we also just had a lot of trouble dealing with the large number of devices that Datto had. So this led us to take several steps to speed up our API. First off, we had to go manually creating the JSON of our devices that was returned, and also refactoring our SQL statements to make them more efficient. We also spent a lot of time determining the best way to display this many devices on the screen at once, without having the users suffer from information overload. And then thirdly, Datto is quickly growing. So while initially we had to deal with 30,000 devices, by the end of the project they were at about double that devices. So we had to build a system that scaled well with this many devices over time.
So with challenges, our project also came with plenty of successes. Our sponsors were very happy with the UI and our risk algorithm. They liked the accuracy of it. The team was also happy with our UI. Our process, Scrum, helped us keep in constant contact and updating our sponsors. It also helped us with risk mitigation and address all the risks we came, especially early on, with the not so well-defined requirements. And as we mentioned before, because of our sponsors' schedule and limited resources, we had to do a lot of things on our own, such as the mock stack, which we were able to handle successfully.
All right, so as Osama said, product-wise, we hit our code freeze, so we're good there, we're done. It's just a matter of the final knowledge transfer, handing the code over to them, getting on their internal Git, some documentation, things like that. In the future, Datto has indicated that they plan to have the web view that you saw in the demo. They plan to have that on big TVs running in a control room 24/7 so they can quickly monitor and see if a device becomes at risk, and they'll know to take the appropriate action. And in terms of the MSP side of things, the MSP web app and the mobile app, we're hoping to get those things on the App Store for MSPs, hopefully soon. And I'll wrap it up there and open up to questions.
So I appreciate all the stuff you did about scale, because that was what was in my mind going through this is, how do you deal with all these devices? Do you have a sense of what is the number of devices that it will have when your system breaks and you need to think about it? So like, you said 30K to 60K. Are you going to have to completely rethink the way you do it at 100K?
You want it? Okay, yeah, I'll take it. So we have done that. I mean, we've ran it at 100K just for our own benefit and sanity testing, and so we actually have hit problems. Throughout this project, even a month or 2 months ago, we went and put in 100K, and things that we weren't expecting were breaking. So we had to rewrite like certain SQL statements. We're using an ORM. We're using Eloquent, and that in itself was causing memory too much memory being allocated because it's creating an object for each of these devices. Jake mentioned we had to manually create the JSON. When we used the Eloquent or the Laravel to JSON method, that was too inefficient for us. So we had to write our own to JSON essentially. So little things like that you wouldn't expect were definitely a huge headache and a lot to focus on. But it's definitely been in our mind throughout the project.
Yeah, and moving forward in the future, the plan is to have the API paginated to return results so that if they do hit huge levels of devices, we can return 50,000 at a time at each point, and it'll scale up to
So then we'll chunk the results, and then at least on the server side, we'll be all set. Casey. That's mostly Angular. Yeah, Angular makes it really easy to do that stuff. The map obviously was Google Maps. Yeah, that's it. Very simple. Any other questions?
Good afternoon, everyone. In case anyone missed Felino, we're now using the purple sheets for our group. That group is For Your Health. I'm Peter Butler, and we'd like to share with you what we've done so far in the last semester and what we plan to do for the next semester. A couple of thank yous to start off with. Hawker's been our faculty sponsor, and Trillium has been our product sponsor, and we're happy that they were able to join us today. Trillium is a local provider of a variety of healthcare services. They do wonderful work for the community. We were happy for the chance to work with them. The work that they do requires a specially tailored solution to a particular problem they were having. The Day Health program, which Trillium runs, has been using a rather tedious paper process for some time now, and they were looking to update it to a more streamlined and easy-to-use digital version. This would help them both serve their customers much better and just make their lives easier in general. And our solution that we wanted to provide for them to this problem was split into 3 distinct components. Number 1 would be the clinician portal, which is what the users will actually interact with. And this provides a much easier way to view all the data and track the patients through the program rather than going through a lot of hard copy documents. The database will replace or at least enhance the existing hard copy repository of documents, and session sign-in will provide a solution to a problem that Trillium was having with tracking attendance to health sessions that they host. To introduce the team, here we go.
I'm Eric Marzak. I was the group coordinator.
And I'm Calvin Diozalia, and I handle the website coordinator.
Peter Butler, and I was the Scrum Master for the project.
I'm Zachary Nielsen, and I handle design.
I'm Dan Hootie. I was the customer representative.
And I'm Karen Snavely, and I've worked with testing.
At the beginning of our project, we wanted to assess any risks that we were facing and come up with a mitigation strategy for those early on so they didn't trip us up later in the project. A big risk that we were worried about was the fingerprint scanner. As I had mentioned, we wanted to provide authentication that patients were attending the day health program sessions, and the fingerprint scanner was the requested solution to that. We were worried about it because it's external hardware and external software, and we weren't sure if we'd be able to integrate that in the time allotted to us. And our mitigation strategy for this risk was to work very closely with developers at the manufacturer of the fingerprint scanning company. And in that way, they'd help us develop a product that will work with the rest of the solution. Deploying the database was also something we were concerned about. We mitigated this by sticking to technologies that we knew were already in use at Trillium. And the shorter project time span for us, it's only a couple of weeks, but it is a bit shorter. And to mitigate that, we wanted to very clearly define the requirements that we had going in. And then once we're delivering to the customers, we wanted feedback to come to us very quickly, so we adopted some Scrum methods to us. At the beginning of the project, we wanted to go full Scrum. Everything was going to be stories and tasks and sprints from the very beginning. In a couple of words, this didn't work. We needed more focus on the requirements at the beginning. There was a lot to get through in understanding the domain. None of us had experience extensively working in the healthcare domain before, and we wanted to really understand what we were going to be working with. So we adopted a bit of a change to the usual Scrum, where we took the first couple stages from waterfall. So we really hashed out the requirements at the beginning in a linear fashion, and we progressed to design. The infrastructure stage, which is existing on this chart because this is the first time this team has been working together. It's the first time we've been working with the customers, and it's the first time we've been working with a lot of the technologies. So the infrastructure stage is there to represent setting up repositories and setting up servers and setting up things like that. And during the implementation, however, we will stick to the original plan of a Scrum cycle where we plan, develop, deliver and test, and then review. And we're hoping that that saves us from delivering a product that would be unsatisfactory.
As Peter mentioned, requirements, that was a huge phase for us. Took us a total of about 6 weeks in order to finally nail down our SRS. We gathered those requirements through weekly meetings with our product owner and through a couple on-site visits to speak with our end users. Through these meetings, we developed an SRS, and that was heavily our focus. We developed dozens of use cases, and even though traditional Scrum is actually based on user stories, these use cases are what we will be using to assign our Scrum tasks moving forward for the implementation sprints. And as Peter also mentioned, physical documents were huge. We were essentially taking dozens of documents and digitizing them, so that factored in heavily into our requirements. So through this, we identified a couple major functional requirements and a couple non-functional. Digitizing the physical documents was obviously key. That was essentially the reason that they wanted this system. And Trillium Healthcare, as a healthcare provider, they are focused on their patients. So managing their patient care plan was a key focus, as well as patient billing. Previously, it was an arduous task to go through all these physical documents and determine whether or not a patient was eligible to be billed. Our system will automate that. Accurate attendance records factored in heavily to the billing process. Previously, it was all done on paper. Now we're going to have a fingerprint scanner. And then generating reports for government audits and for the internal monitoring of day health as a program. The non-functional requirements, none of us had dealt with HIPAA compliance before, which is actually basically a system to maintain and protect patient confidentiality. So we had to kind of pick that up and implement that. And usability. Our end users, they vary in their technological skills and capabilities, so we had to have a heavy focus on that. And through this, we identified a couple architecturally significant requirements. Those were the flexible database design to handle the different documents and their complexities. We needed to support easy integration of physical hardware in the fingerprint scanner and the external application that runs it. And we did this through a web-based implementation, as was requested by our customer, and it also allowed for platform independence.
All right, that brings us into the design aspect of the project. As you guys can obviously see, we're replacing a paper data system with a digital one. So the data is definitely the star of the system here. So what we wanted to do is we wanted to do data-driven design where we start with the data and then kind of build around it. So we really started looking into the database early and how we were going to design that. A huge feature for the database is this maintaining of documents with variable tracked data. So what that means is, in essence, if someone at Trillium wants to add a new document to the system, maybe it's some new health form that they need to keep track of that has blood pressure as a variable that they now need to start tracking, we need to be able to not only be able to accommodate that document, but we also need to be able to accommodate blood pressure as a variable that they need to track. That's a pretty big thing. We were talking about it for quite a while. We believe we came up with a good solution for it, but that brings in another problem we have, which is after you have all of these blood pressure data points, the customer would also like to run statistics over them. So they may want to say something along the lines of, well, let's look at patient A's statistics for blood, for their blood count or something like that over the past 6 months. And they want to be able to see a nice table of all the values and how things have changed. Finally, there's also auditing. A big feature to the database is they have to keep track of every change that's ever made. So that was something we had to think about a lot going into it. Cool. So the first decision we tackled was the idea of these fields that we need to be able to keep track of and run statistics on. So this is a little excerpt out of our database schema. We have fields, which are in essence an abstract piece of data that are associated with a document. So when you add a new document, you're going to add a bunch of fields, like let's say blood pressure is one of those fields we added. And every time someone uploads one of those documents, it's going to link that document instance with a field instance. So the blood pressure would be the field instance, which would be able to be tracked to the field, to the document, whatever you needed. This allows us to do some crazy things like run statistics over all of the different patients with one field or one document or stuff like that. These field instances, though, because we have multiple types of data, we have integers and strings and doubles and all this fun stuff, we have to have a separate field instance table for each type because we can't store the value as a different type in each table. So that was a solution we had for that. And also for the audit table, what we really decided we should do is any changes that are made in the system, we end up keeping track of the previous value and the new value in an audit table that can easily either be rolled back, or you can go through and you can say, what did user A do to this patient today? Okay, they changed these things. So that was our solution to auditing.
So this is a high-level overview of the architecture for our system. We wanted to completely separate all the different components of it, being the session sign-in, which is handled by a laptop or other endpoint with a scanner, and a desktop client for the clinician portal. These can communicate independently with the server, which hosts RESTful API services. And within the server, we modularized it to components of controllers with models that use the database with database controller that communicates directly with our SQL database. For the technologies that we chose to use to implement this, we went with AngularJS for the front end because we can handle a lot of the functionality, as well as it makes it very easy to consume RESTful services. Spring for the server, which makes it quite easy to set up RESTful services and models to communicate with the database. And we chose Microsoft SQL Server because it is a technology that Trillium is already using on their servers. And then for DevTools, we went with Maven for package management, Karma for JavaScript unit testing on multiple browsers. We hosted the repository with Git. We also used Apiary, which I like to highlight. Because we're going with a third-party service for the fingerprint scanner, we thought it would be very good to document the API very thoroughly, and we think it's going to pay off really well because we gave them access to that, and now they know exactly what kind of RESTful API endpoints they can consume and use. Now we're going to show you a recorded demo.
If I can find that house.
So this is as far as we've gotten in the application. We have the ability to log in and log out right here. So we chose for the homepage to be 4 of the most, what we thought would be the most used classes, being patients, classes, statistics, and documents would be things that people would want to probably hit earliest. And then on the top, we have a global navigation bar. This is a view that we plan to use for almost all of the main features, or the main pages that you can view from the home page. And this search bar is very easy to use. You can literally type in any of the fields that are in there, and it'll filter based on that.
Still hard to find the map.
So, as mentioned previously, we had come up with some risks that we identified, and we actually came into some of the problems that we had ran into along the way. We had originally planned on doing the session sign-in application by ourselves. We had ordered a fingerprint scanner, and one of the risks we had identified was if we ended up with one that didn't work for some reason. And as it turned out, we didn't get access to the SDK, so we were unable to develop with it at all. So we ended up following our mitigation solution that we had for that, which was we set a hard date where we needed to find another solution for the fingerprint scanner. If that one was not working, and the solution we found was working with 360 Biometrics, and they're actually assigning a dev team that's going to be altering one of their applications that's very similar to what our session application was going to be for use with our system. Another problem we ended up running into that was unexpected was some integration problems. It turns out that Microsoft SQL Server and Spring don't necessarily like to talk to each other very early on, which we hadn't really expected that to be an issue, but we identified it once it started coming up and tried to develop a mitigation strategy where we've involved the use of several experts in setting such things up, and we've finally got that all cleared up. And so we've now moved on to focus of starting our tests running and stuff like that. Due to the issues we ran into, in addition to the standard unit tests and such, we decided to put a heavy focus onto integration testing with bringing in the third-party software into our system. We have that as a possible point of weakness, so we wanted to focus very heavily to make sure it'll all work together, and also make sure that our connections with the database stay stable so that we deliver a working system. And then we also decided to put a heavy focus on usability testing to cover the variability in our end users' technology skill level, and because usability was one of the most strongly stressed requirements by our product owner.
Alright, so far this semester we did gathering requirements and making designs and setting up the interfaces. And starting next semester in summer we will be developing features for this sprint. And the features include application for billing, patient information, generating documents, and class sessions. And also we will be integrating those features with the actual live system with Trillium Help. And we also will be giving them training on how to use the application. And also we will be doing the final requirements for our RIT senior project, including making senior poster, giving a final presentation and demo. And that's all we will be doing for the next semester. So we have any question?
You mentioned that your system interacts with other external systems. How flexible is your system if you want to add another external system from the architecture?
So just to clarify a little bit, it's not truly an external system. It's a system that we're having designed for us. It will be external to our network at times, but it will then be brought internally. The REST API endpoint is designed so that the third party can develop the application using apiary as a point of reference. They can know exactly what calls they have access to, and if need be, if they need more calls, then they can bring that up to us as an issue and we can generate more.
You mentioned that you might have users who are on the lower level of technology usability. So what is your plan in terms of usability? Are you going to be able to have access to people and be able to test this interface? Or
Yeah. Actually, so we're working on wrapping up our prototype. The one that we showed you, we're going to basically flesh out all of the views, and then we're going to start beta testing over at Trillium. We're going to bring the application over there, have our end users actually work with it, get consistent feedback, and hopefully work with them every sprint cycle to give them improvements that they're looking for.
That's our plan.
How many users?
There's not many. I think there's a total of 4 clinicians. There'll be a couple facilitators who actually host the class sessions and stuff like that. They occasionally bring in outside people. A relatively small user base, though.
One thing important to note, though, too, is that they do intend to hopefully use this system for other groups as well. So that's something we have to keep track of.
Has HIPAA thrown any curveballs at you yet and adhered to any weird rules that you didn't know existed before?
Actually,
not in particular. We keep looking things up, and it turns out that HIPAA, they don't provide like specific implementation details for a lot of requirements. They just provide, general things like, your tokens actually time out, so sessions don't just last forever and other things like that.
Patient names can't be stored as plain text.
We actually also dodged some bullets there. The other Trillium team, they are actually pretty much wrapping up their system, so we're able to kind of converse with them, figure out how they got around the HIPAA compliance as well. So we did have a useful tool through them.
Emma?
Okay. Are you guys using any product or process metrics at all?
Yeah. So since we're using the Scrum system, we've been tracking our burn down chart, points per sprint, and then we're also comparing hours spent on parts of the project so we can see what takes the most time, if people are able to keep up consistent hours per week. And then since we'll be user testing it, we're going to be taking as much feedback as we can get from the users. Yeah. And finally, once we're doing these deliverable sprints, we'll be tracking bugs and issues to see, how our code trends.
You mentioned that you switched from Scrum, and I'm just wondering if you were able to assess what was the impact on your schedule when this happened?
Yeah, so there was about a week or two of, I don't want to say flailing, but that's the word that comes to mind, that we adapted to as fast as we could when we realized how heavy the requirements and design were going to be, and that we weren't going to be producing deliverables as soon as we wanted to. So that's kind of why Waterfall suited us better at the very beginning.
We did story point out our SRS document.
Yeah. But for a couple of weeks, we were transitioning. The good thing is we had planned out when we wanted to get certain things done, and we'll be able to deliver prototypes at that time. So it didn't hold us back in delivery. It just gave us a couple weeks where we did more work than we probably should have.
Yeah, it was one of those things where we were doing Scrum and we realized our first couple sprints were very requirements heavy, and then our next couple were very design heavy, and we were kind of starting to say, well, are we really, is Scrum exactly what we're doing? Probably not exactly. So Moving forward, we are going to keep with Scrum though, so.
So. Sure. Good evening. We are Team Ulysses with Trillium Grant Management. I am Matthew Metcalf.
I'm Shannon Trudeau.
I'm Ashley Clarnowitz. I'm Brian Tuck. Tonight we'll be going over our project, our design, go over a quick demo, our reflection, and finally our final project status. Trillium Health is a nonprofit health clinic based in the city of Rochester. Trillium receives the majority of their funding through public and private grants. The problem Trillium was having was keeping track of so many grants was becoming cumbersome. Over time, having over 20 grants at once. Our project solves this problem in 3 ways. First, grant management. Grants are funds received to Trillium to fund different initiatives inside of their company. Grant management is done by allowing users to keep track of the status of a grant through its life at Trillium. Second, task management. Tasks or any objective need to be completed on a grant. So, task management is done by allowing users to create tasks, assign users to tasks, and set reminders on tasks. And finally, document management. Documents are anything that needs to be saved inside of our system for a grant or task. This is done by allowing users to upload and download the documents, also keeping track of versions of the documents over time, allowing them to revert to a previous document if need be. Additionally, we added some other features that Trillium wanted. Workflows are an already existing construct inside of Trillium. Workflows can be anything from audits to reapplying for a grant. These can run both concurrently and in sequence of each other, so keeping track of tasks and documents in these are important. Audit trails are keeping track of who did what when, so they can see who changed documents or tasks or grants, so they can find out this information. Authentication and authorization is done by using Trillium's already existing LDAP server, so users are able to log in with their everyday usernames and passwords for Trillium, so they don't have to memorize a new set of credentials. Outlook integration allows users to subscribe to a webcal so that they can get tasks added to their Outlook calendars when they are assigned to tasks, so they have an additional reminder of when that task is due.
finally, status emails. Status emails come in two forms: weekly status updates and reminders. Weekly status updates are an email sent out to users each week reminding them of tasks that will be due in the next 7 days. Reminders are additional emails that a user can request to be sent out a month, a week, or a day, or a few hours ahead of time, depending on what they want.
So with the scope being so big and so many things to consider, we focused our design on 3 main quality attributes. We looked at usability, security, and modifiability. So with usability, people often talk about this idea of ease of use. How easy and usable will this application be for the users? So within usability, we looked at 3 main components of usability. We looked at learnability, and we asked ourselves these questions. Will the users be able to adapt to this application fairly quickly? Efficiency, will the users be able to perform tasks quickly enough? And lastly, we looked at satisfaction. Will the users feel pleasant and at home when using this product? Now, all these concerns are application solved by having an integrated, by having a consistent design overall, which you'll see in our product demo. So with security, we also had to consider HIPAA-related documents and tasks. So we had to authenticate our users via LDAP and session, by using LDAP and session tokens. We also had to keep an audit trail of everything that was happening within the system at all times. We had to sanitize our inputs with forms, and we also had to keep track of user roles. So if a particular user can be assigned to financial documents or whatnot.
So Trillium wants to have this application run for quite a long time. We want to be able to get the best bang out of the buck, right? So we try to focus on the two different parts of our application: our client-side code and our server-side code. For the client side, we created a page scaffold, which is a quick way to add new pages into our application in case anything new comes up. Also, we decided to lump related JavaScript and HTML into a module that we created, which is basically a folder. This way, if anyone wants to change something in our application, they can just go straight to that folder instead of having to hunt around different places. Finally, we also made development mocks on our JS front end. That way, you can test your application or test parts of your application without having to send requests to a server, like a live server. On the server side, we decided to use JPA entity managers in order to manage persistence and retrieval of our objects or data. We also tried to separate interfaces and implementations. This was done since for different environments we may want to use one certain implementation but not another. And this way we can tailor it to our needs. And finally, we decided to use configuration files. That way, if any configuration in Trillium changes, like their authentication server, we can just change one line and then boom. So we decided to stick with the traditional 3-tier architecture since this is a web application. On our front end, we have controllers and services. Controllers handle the display, are responsible for the display of data. Services are responsible for sending AJAX calls to our REST server and any small business logic that may be there. On the server side, our Spring controllers are responsible for handling those requests and sending responses back. Our services are responsible for any business logic that may go on. And our data access layer is responsible for persisting that data and retrieving it. So, on the software engineering VMs that we provided, we decided to set up a staging environment, basically something that we can test on. And in this environment, whenever we push code to our repository, our Jenkins instance compiles all the necessary artifacts and then deploys it to our Tomcat instance. And there we can test on as much as we want. And our application connects to our database and our authentication services. Likewise, on Trillium's production environment, we also have a Jenkins instance. But instead of monitoring master, we monitor a different branch, and whenever you push code to that branch, it'll also do the same thing as here. It'll compile all the assets and then deploy to the Tomcat instance we have. It also connects to our database and authentication server. Well, their database and authentication server. So some of the trade-offs that we came across. We decided to use third normal form when designing our databases. The advantage of this is it makes reasoning with our data much, much easier. The drawback to that, the potential drawback, is that queries may be a bit slower. And since our data model is quite complicated, we decided that the benefit of using third normal form outweighed the cons of potential performance issues. You can always fine tune them. Also, we decided to value security over performance. When we first do our LDAP calls, or try to authenticate via Trillium's environment, those authentication calls could take upwards of 2 seconds, and that could have been a problem. So rather than trying to hack around a solution that may be a bit more insecure, we decided to stick with the code that we have now.
Okay, so now we can talk a little bit about the testing that we did for this application. Like Akshay said, usability was one of the main quality attributes that we looked for. So what we did was a lot of manual testing and user testing. So at the end of each of our construction phases, we were able to create test scripts and give them to employees at Trillium that highlighted the features that we had just completed in the previous construction phase, and then they were able to run through those and check out our system, do some user testing, and then at the end, we had them fill out the SUS metric like some other teams did, which is basically a 10-question survey that highlights usability of the system. A typical score for that is a 68, and we got an 85, which we're really excited about. Some of the challenges that we had with testing were for unit tests. Out of the unit tests that we had hoped to complete for the system, we were only able to get 60.5% completed. So this meant that at the end of our construction, we were doing mostly the manual acceptance tests and usability testing as opposed to the unit testing, mostly just because of a time constraint. So now we're going to do a demo. Do you want to? Oh. It's up here. Just go to this one. Yeah. Okay, so this is our system. On the left, you can see grants that have already been put into the system. So right now what Matt's going to do is add a new one. And so he can type in the name of the grant, select a primary funder, the amount that was awarded for this particular grant, give a quick description, and then select the status. Status is our active, meaning we've already received the grant, potential, meaning we're hoping to receive the grant, and discontinued, which means that we're done working with this grant. And then they can put in any web addresses that they want to, like the website of the funder or something like that. So now that we've created the grant, you can see it on the left-hand side, and he can click on that, and then it will bring up underneath the information tab all the information that he just entered in about the grant. So the next thing that we're going to do is add a workflow to this grant. Typical workflows are like applying or auditing. And so he clicks the green plus sign again, and that'll open up the modal for a new workflow. He can enter in the name of the workflow and select a start date for that workflow, which can be anything that the user wants. So now we have our new workflow. Let's add a task that can be completed within this workflow. Again, green plus sign. Enter in the name of the task, select the workflow that you want this task to be completed within, and select a due date. He can check whether or not he wants the task to be signed off by the grant owner or by his supervisor, and then write a quick description about what the task is supposed to do. So now we have our task. The last thing we wanted to show you was adding a new document. So if you go to Documents, we can hit the green plus sign again, and enter in the name of the document, select whether this document contains financial information or not. If it does contain financial information, then only users that have the financial role privilege will be able to see that document. And financial information is stuff like payroll and things like that. And then he can upload that, and that'll be in our system. So that was just kind of a quick overview of the main features of our system. There you go.
So, like in every project, there's things that go well and some things that didn't go well. So one of the things that did go well was our sponsors. We had good synergy with the sponsors. They were really provide a lot of good feedback for us. Also, The other thing that went well were code reviews. So with code reviews, we were able to catch a lot of bugs early, and they also kind of kept our team in sync with the code base. Like whenever we push out code, everyone could read it and then know kind of what's happening. Also, those code reviews sparked a lot of discussion related to requirements and implementation, and they helped resolve a lot of problems that could be potentially bad down the line. Finally, even updates. They worked this time around, and this helped get the team on the same page with what everyone else is doing, and also they helped us keep on track of any deliverable or anything else that we need to do on this time. So, like I mentioned before, we did have a Jenkins instance up on Trillium's production machine, production host. However, we couldn't get it to work as we expected to. So, at this point in time, all deploys are manual for production. And we encountered a few problems related to deployments towards the end. Also, LDAP and Outlook caused a few problems for us, mainly because the time it took for researching and integrating these two components took quite a long time, and we didn't really have that much experience with it. Also, Outlook was particularly hard to test on Trillium's environment. And finally, even though everyone on the team were responsible for many areas of our project, no one was really responsible for integrating all the code together. So when we tried to do integration, there was a lot of unanticipated work that we had.
So we'll be handing off our final project to our sponsors on May 15th, along with a demo and a training session. Some of the features that we were unable to deliver were task templates, subtasks, and automatic workflows. If any senior project teams do pick this project up in the future, we're hoping that they would do something along the lines of recycle bin for documents, document tagging, so if a document is a healthcare-related document, then document be a healthcare document, and use a proxy for administrators, so administrators can come in, proxy as a user, and help them out if they need to.
So we wanted to thank our team coach, Kratz, and our sponsors, AJ and Russ.
That's all, folks. Synergy. Any questions?
Why Team Ulysses?
S. Grant.
Ulysses S. Grant. Ha 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 ha. Jokes.
So, it seems like it has things like workflow and stuff. How is it different from something like just a SharePoint server or something like that?
We fielded that question a lot. I think one of the reasons that they wanted us to build something outside of SharePoint was because SharePoint was kind of cumbersome and had a lot, and they wanted something that was more usable, and just they didn't like SharePoint. So in that sense, another thing that's a big point is the workflows. So that was something that they use internally at Trillium and that we implemented within here that kind of helps them organize by time frames and by processes.
Yeah, we spoke to our sponsors and they were okay with having some latency within our application, but they wanted security over performance.
We're ready.
All right, we are Team Simple, and our application was Simply. It's not a misspelling, it's actually a combination of the words simple and supply. I'm Michael Yapel.
For the Spurtner.
I'm Mustafa.
And I'm Jeremy.
All right, so this is our agenda for the day. We're going to go over some background information and then get into what the actual goal of the project was, as well as the technologies and architecture behind it. We're going to talk about the current status of the project, do a quick demo, and then get into future work, challenges, and a reflection of our project.
Now, if any of you have ever been to Wegmans, you'll notice that they sell more than just your favorite cereal and Hot Pockets. They sell non-food items, your pots, your pans, your cheese graters. The area that our project is concerned with is seasonal general merchandising items. So I want you to think more of Santa dolls, Easter baskets. When you walk into a Wegmans store, you will typically see a display of seasonal items. This is known as a planogram. It's a logical grouping of similar items that are put on display so that you will buy them, and you will hopefully buy them before the season is over, because after the season is over, your Easter baskets become much more difficult to sell, and Wegmans has to mark it down until they're practically giving them away. So they already have a process in place to handle this. They Wegmans hire what are known as buyers. The buyers, using Excel spreadsheets, very complex Excel spreadsheets with lots of fancy macros, and email, they collaborate to distribute the product in their warehouse to various stores. Now, each Excel spreadsheet represents one item across many stores, and it contains sales information, it contains historical data, it contains algorithms to distribute the product to each store. Now, when they are examining an item, they are deciding how much of this product to distribute to each of their stores, and there are several factors that go into that decision. Now, after a buyer has decided how much to distribute to each store, they copy the column that represents the distribution information, and then they paste it into another application that will handle their that distribution. So this is kind of the flow of product through the supply chain. They buy the product from the vendor, it ends up in the warehouse, and the portion our application is concerned with is getting it from the warehouse to the correct store in the correct amount in order to hit the demand curve so that there aren't any Easter baskets left after Easter is over.
So as Curtis mentioned, the real goal of this product is to deliver the right product to the right store at the right time. What that means is creating projections of the amount of product that should be pushed to each store using data such as specific item data, store data such as how much shelf space is available, and then sales history data. Other goals include improving upon the current process that these buyers use. What we really want to do is we want to eliminate a lot of the extra tedious work like copying and pasting things into another application, navigating between different Excel files and opening them in order to find a distribution for a new item. And so we want to streamline that process a lot with this application. Lastly, there's potential to automate most of the workflow with this application. Eventually, if the algorithms get to the point where the buyers can trust them on a whim, they can take and they can finalize a whole planogram at a time without even looking at the distributions, and then just it gets shipped off to the stores. So this is our tech stack. Some things to note are TFS we used for project management, such as tracking our user stories, tasks, time management, as well as our code repositories up there. We use SQL Server. In specific, we use stored procedures for all of our interactions with the database. These are faster than just writing SQL statements and sending them to the server because you don't have as much network traffic between the application and the SQL Server. Also, we use Dapper as our ORM, which is a really lightweight ORM. It's a single C# file, and it basically takes the data that we get from SQL Server and maps it into a C# object so that we can use it easily. We also use AutoFac as an inversion of control container for dependency injection. For example, if we create a new controller, we can tell AutoFact to resolve all the dependencies that we create with that controller, and we don't have to manage any of that on our own. It's important to note that Wegmans recommended a lot of these technologies to us because it's what they use and it's what they're familiar with. We investigated other alternatives such as InHibernate and Spring, but they were very comparable, and on top of that, we wanted Wegmans to be able to maintain the application easily, so we wanted to go with something that they were used to and able to manage.
So, when we were developing this application, we decided to split it up into a web application and an engine. Now, the web application is going to handle all the presentation of the user. This is what the buyers will see when they use this web application. They won't see the engine. The engine's going to manage all of the jobs, including importing Wegmans data into our system, as well as calculating all the distributions ahead of time so that it's not done on the fly when you load up all the items. You'll notice that we have the same data access and data layers across the web application and engine, and that is so that we don't have duplicate code in multiple places. That is the same libraries just used in both of those, as well as our cross-cutting features. Additionally, we have this engineered in a way such that the engine itself, the web application, and the database can all be on separate servers, and in this way, the application is very scalable because they don't have to have it all running on one machine. They can spread it out, which is very nice.
Let's talk about testing. During this semester, we only did pair programming for complex issues that required more than one team member expertise. For unit tests, we covered every single complex part of the system. And we also conducted acceptance tests in two stages. The first stage for acceptance test, we went and derived validation criteria from the user stories we committed to. And at the end of the iteration, we went and with the customer and went through each validation criteria and make sure we satisfied their needs. Also, when you look at the testing scripts, it's not in the software engineering world we refer to like automation tests, but we borrow that term from Wegmans. It actually refers to black box testing, and where you have set of scenarios and expected results. But we also add a new element, traceability, to see what each scenario came from, what user story. So the current project status. As of today, we completed 9 sprints. 7 of them were dedicated to deliver core functionality, and 2 of them were just figured to do the polishing. Instead of delivering a rough product, we thought we'd deliver a more robust project by focusing on added at the end of the last 2 iterations. And we also delivered 45 user stories, which is almost double what we did first semester. And during the spring break, we went ahead and improved the UI, and it was a game changer at that point, and we'll talk about it later. And next 2 weeks, we're looking to go to Wegmans. I think next week we have an appointment with them to help them out putting the application on their testing environment with the help of the Base 2 team in Wegmans. So now we'll go with Jeremy and show you our awesome product. Demo it.
Just drag that to the MMR.
Yeah,
So I need to have the speaker for the items. So.
Yeah.
See if we can. Yep, we're on projector only. Does that duplicate? Oof, that's not gonna work. All right.
You cool with extending?
Yeah, as long as we just drag the tab over. Oh, right, I gotta look like this now. Okay, so as a buyer using this system, as soon as you get into the system, this is the page you're going to land on. This is the Season Explorer. It will show you all of the seasons that are currently active within our system. So you can see stuff like Easter season, the summer season, winter, etc. If you drill down into one of these seasons, you can click on them. And now we have all of the planograms in that season. Now in the everyday seasonal items, we only have the one planogram here, the everyday seasonal items, but we can take a look at a different one real quick and note that there are lots of different planograms in each of these. So further down from here, we can look at each planogram and see all the items that are a part of that planogram. One thing to notice as we're going through these Explorer windows is that our look and feel is the same. All of these tables are very similar in that you can sort on these columns, any of these columns, or you can show and hide columns as you please.
from this here, we can drill down more granular into one item. And this will give us the distribution information for each of the stores here. So this is a list of all of the Wegmans stores. So as an analyst, you want to see as much information as you possibly can. But you don't necessarily need all of this information. So we have the ability to hide columns that you don't need or change the order of columns as you decide you need them. So I don't necessarily need the store ID. I know the name of the store, and that's good enough for me. I'll hide the store ID, and for the sake of this example, I can move the segmentation up above the name. You'll see here that the name and then the segmentation is that way. If I save these here, the page will reload, and you'll notice the ID is gone, and these are switched. Of course, you can then also revert back to the default. So once I'm on an item like this, I actually want to be able to start making a distribution across all these stores here. Now we have these distributions that are pre-calculated when we import the Wegmans data. But suppose I know that this shopping cooler medium size is a big mover at the Wegmans stores. I know that they're going to need to initially stock the stores with a lot more than normal. I can recompute one of those algorithms. So the setup algorithm is used for initially stocking a store, and by default we distribute 25% of what's in the warehouse. Let's make it 30. So we can run an algorithm, and this actually uses our engine. It makes an API request to our engine and reruns it with those new parameters and lets us know when it's finished. When it is finished, we can refresh, and you can see the new information. So you can also choose one of these distributions, and when you do, it'll populate the ship distribution fields on the side here, which is how much of each of these products is going to be shipped to each of these stores. It'll also give you a live update here of the units that we will be shipping so that you can ensure that it is less than or equal to the amount that you have on hand, because obviously you can't ship more than you have. Once you are done messing with this distribution, you can obviously give certain stores a little bit more or a little bit less. I can't see, so I'm not going to do that. You can go ahead and save your work. And what saving your work allows you to do is basically, if you go to a different item and are working on a distribution for that item, and then you come back to this item, any work that you've done, anything in that ship distribution column will stay there. So let's say now, I can show you that by refreshing the page. So now that I'm done messing with this distribution, I have it exactly how I want it. I want to finalize it. And what finalizing it is going to do is going to make it so that this is no longer editable and it's ready. This item is ready to ship out to the stores. This window is for finalizing a distribution. You have these different types here. So out of inventory, this would be in a case where you want to push the rest of your product out to the stores because that store is out of inventory. Then you can choose your pick week and ship week. You'll notice that this is a 1 to 52 right here, and that is because it operates on fiscal weeks. The pick week is the week where we actually pick these items out of the warehouse, and the ship week is what week they're actually going to be shipped to the stores. So we can just fill in a couple values right here like that and finalize the item. The item will be finalized, and you'll notice you can no longer edit any of those values. So now that I finished one item, I'm going to want to go to the next item in the planogram. Since a buyer will have to do an entire planogram or more than that. So we have the ability to go with these next and previous buttons to the next item. You can also use the arrow keys at this point. Left and right will navigate you. And now we're on the large cooler. So that is one way that you can go through these items. If we go back up to the Item Explorer to look at all the items, you'll notice that the item that we were just playing with is now finalized, and it has its distribution picked. So we can go through every item in a planogram and make a distribution, but that is one of the things we're trying to help them with, is speeding that process up. So here on the Item Explorer view, we can run an algorithm at this level on multiple items and finalize multiple items at once. So of course you're going to need to select some. Let's just select the entire planogram here. It doesn't select the finalized one because it's already finalized. You can run an algorithm on all of them. So let's run the push all algorithm. And you have a nice little progress bar down here, which will show your progress. And it is going slower than normal. Yeah, so that will, I don't have enough time to switch pages, but if you switch a page, it'll pop back up, so it knows that you still have jobs running, and it tells you it's successfully completed. And now I want to finalize all these items. I trust the push-all algorithm. So I'm going to use the push-all algorithm. Again, you get this confirmation window. So I'm just going to pick this first one here and put similar information. And now we've finalized the entire planogram. If we go up to look at the planogram explorer, we'll see that the entire planogram has a status that it is finalized. And so these are just some of the tools that we've implemented to kind of help buyers in making their distributions and making sure that we get the right product to the right stores at the right time.
Yeah, there's too many windows. No, it was the demo.
All right, so this is there's some remaining work to be done by Wegmans, and we're going to graze over a couple of points because we're running out of time here. One of the things that what's remaining for Wegmans to do is attach a scheduler. They have an actual scheduler they've built in their environment to run our import data job from our engine. What that means is our import data job, or our engine, as we said, has a job controller, which is actually an API controller. All they have to do is ping it with their scheduler, and then it'll kick off the job to import all the data from their systems, and then run all the algorithms on that data. Another thing that they have to do is implement a store view in which each individual department in each store can see what product is coming to that department in that store alone. They don't want them to compare between departments or stores because then there could be issues and they could be complaining about why they're not getting as much product as some other store or department is. And then the last thing would be adding new algorithms. There's always potential to create new algorithms that create nice distributions for them to get their product out.
So, like every project, we experienced some challenges, one of which was requirements gathering. Most clients that you interact with are not going to have all the requirements for their system that they want up front. And to mitigate this, we made sure that we met with our sponsor at least once every other week to ensure that what we were delivering and developing was what they wanted. We mentioned that we had a UI overhaul at one point. When we initially did our UI, we didn't do the bestest job on it in that we didn't use Bootstrap or any technologies like that, so we did have an informal iteration to do something like that. We had an inconsistency in our local and production databases, which is basically saying that we had some information that needed to be primed in our database that we had in our mock data creation script instead of our just our database creation script. So when we created our production database, it wasn't there since we were using real information rather than mock information. And that took a while to track down, but once we did, we made adjustments and now know to look for something like that. And finally, technology approval. When you're working with a company like Wegmans, they want to make sure that any third-party libraries that you're going to use, any other technologies that aren't ones that you're creating or ones that are theirs, are going to be updated frequently, supported, etc. And so this means that most of the technologies that would be approved are paid solutions. And yeah.
So we have a number of things that we did really well during the project, and we have a few things that we felt like we could really learn from going into the future. The first thing we thought we did really well was managing expectations. We certainly didn't promise them a pie in the sky and then deliver meatloaf at the end. We told them up front that we weren't front-end developers, but then we were able to exceed those expectations in vastly improving the UI in our second term. We were able to deliver some wow features like making it mobile friendly, allowing them to edit columns. We've already gotten an early start on deployment. We've given them the support they need through documentation and via email. The deployment should be finished in about 2 weeks, and it'll be running on their servers. And above all, we have a very satisfied customer. Some of the difficulties include a late sprint planning, which would kind of mess up our burn down chart. Once in a while, we would get a bug in the demo, and we would fix it the next day. And we did want to achieve more stretch goals, but we had to weigh that against delivering a polished core experience versus gold plating something that might be a little more rusty underneath.
After all said and done, our application had added a great deal of benefit to Wegmans. So instead of the user working on one item at a time, now is able to work on multiple items. So that speaks to our application's efficiency. As well as, so whenever user performing some sort of calculation or recomputing, the values will be displayed right away. That speaks to our performance as well as the way we engineered the system. Also, in the current managing system they use, the user has to interact with multiple systems, like copy and paste in different data from one place to another, and then compute, and then send the finalized results into the mainframe work. With our application, what we did, the user only interact with our application, and then finish everything, all the computation and all that, and then convey those information to the mainframe. And since the system is no longer Excel based, so there's no longer for Excel expert. And we also, it's worth to mention that we also met some stretch goals. At the end of iteration 7, the customer came up to us and introduced a new requirement that was critical to the system. But we took this requirement and we implemented it in a timely manner. It's also worth to mention that we set a new standard in Wegmans IT department by introducing the mobile-friendly application. And at the end, we're very proud of what we accomplished, and I believe our customer shares the same view. In fact, this application was only designated to be used in general merchandise, but we hear that this application is going to be utilized in other departments within Wegmans. So with that being said, I would like to open the question for, I'd like to open the floor with Q&A.
So you said that multiple users would be editing the same Excel sheet. Does the new system support that as well?
Sorry, I hope I didn't say that, but generally they have one user working on one spreadsheet at a time. That actually was a concern that came up. We were worried that they would want multiple buyers working on the same item at a time, and we began to worry about concurrency, but that requirement was flushed away rather quickly.
The way it's engineered in the engine, they will only need to make a new algorithm in a class, which will take distribution information, or it will create distribution information from various whatever they need for that algorithm, and they'll also need to create a job class that can be kicked off via the job API. They don't need to modify anything. Yeah.
So you guys mentioned buying cheese graters, and you guys are part of Wegmans' team, so I assume you guys have the best cheese product. What's the best cheese?
Let me tell you this. I got this.
You got this.
Now, this is a highly debated topic, but I think we can all agree that the best cheese is provolone. And if anyone asks you why it's the best cheese, this is all you got to tell them. It's got pro in the name. That's how you know.
I think on that we'll follow it.
Good job, sir.